Let's have a quick look at the Java syntax for conditionals, which is simply a fancy word for if-then-else constructs. In fact, in this respect, Java is derived from C, C#, C++, so if you know any of these languages, there's nothing new for you to see here. Imagine, as an example, we're looking at a program that would simply get some input from the user and then check if the input is a positive number or not a positive number, and either processes that input or complains about it to the user. How would you do this in Java? The syntax looks like this. You would use an if-else block, and this is simply the keyword if followed by a Boolean condition in brackets, followed by a block of code that gets executed in case the condition evaluates to true. And then this might be followed up by an else clause. So here's the keyword else, which is then followed by a block of code that gets executed in case your condition evaluates to false. Now, what can you put into this condition? What can you check here? The answer is any Boolean value, meaning any expression that evaluates to either true or false. This could be true or false directly, but that would be boring. And instead, you can use what's called relational operators. And these are functions that take two inputs and return either true or false. Classical ones are strictly greater than, strictly less than, equal to, the weak comparisons, or not equal to. So for example, if you have constant 5 on the left-hand side and you compare it to x, which is, let's say, an integer variable, then the whole expression here evaluates to true exactly if x, the current value of the variable x, is strictly less than 5. You can combine several such conditions using Boolean operators, not, and, or, XOR. Here's an example of a Boolean expression, which is a combination of smaller ones. The first bit here is what we've just seen, that asks that the current value of x is less than 5. Similarly, the current value of x should be bigger than 0, and together this means that the current value of x needs to be strictly in between 0 and 5. We can write this as a tree. This 5 greater x, x greater 0, and now we will negate the whole condition, which means looks like this. And on the right hand side, we ask that the current value of x minus 5 is equal to 10. So this asks that x is equal to 15. And the whole thing is a big disjunction of the two. So this means the condition is equivalent to this logical formula, and if you think about it, it simply asks that the current value of x is not one of these 5, 1, 2, 3, 4, or 15. Every other value of x will make the condition evaluate to false. Now, how would we implement the toy example just mentioned? Well, it's very simple. It's just a single if-else block, and the condition was input x needs to be positive.